Okay, now we are going to see the third method which is being used to measure the residual volume, that is body lithosmography. Already we know the meaning of lithosmography. So lithosmography is nothing but volume changes. Here we are going to concentrate your volume changes of your body. So that is the reason you have name like body lithosmography. Here we are see the picture which I have placed below the content. So you can see the picture of one box. Inside one box the person is sitting. Okay, that is a closed box, closed compartment. The box volume is, and then inside the box have some pressure, and then the patient is sitting inside. So patient lungs volume, the lungs volume, and then patient pressure. Okay, so here these two things is which is involved. Okay, this body lithosmography, as I said, it is going to measure the changes in volume. So here this body lithosmography follows a principle called Boyle's law, whereas in previous two case it follows a principle called law of conservation mass. Here we will see the it's called Boyle's law, that is uh, uh, yeah, pressure difference under volume difference. P1 V1 is equal to P2 V2. In previous case we discussed C1 C2 is equal to C2 V2. Here P1 V1 is equal to C2 P2 V2. That is, here we have involvement of pressure. In previous case we had involvement of concentration. Okay, so see the picture. So we have two type of difference here. Okay, we are going to see difference of this experiment at time of expiration and inspiration. So inside a closed compartment, the patient is sitting inside. Okay, you have two pressure gauge. One is to measure the pressure of airway pressure, which is being connected to the mouth of the patient. Second one is to measure the pressure of volume, box pressure, which is connected to the box. Okay, so we have to understand one concept, that the pressure under volume is inversely proportional. Okay, so you already might know that whenever the volume is increasing, the pressure will decrease. Okay, consider the classroom. It's a very big classroom. It's very spacious. It is very spacious in the sense the pressure is very less. Okay, the volume is more, the pressure, it is be very spacious. You don't have anything to be suppressed or something. So what will happen, the pressure, you have very less pressure. In same case, in same level of room, you are occupying, you are dumping with 50 people. Okay, now what will happen, the volume is getting reduced, right? The spacious volume is getting reduced. You have constant volume of room, and what happens, since you are putting or dumping with nearly 50 number of people, it means that the spacious volume will get reduced. Okay, so as a result the pressure is getting increased. Okay, so this is the concept we are using here. Here we are using volume and pressure, both are inversely proportional. So when the person, okay, the same concept here we are using in no constant box, in the constant volume of in box, box volume, the patient is sitting inside, right? So when the patient is inhaling, what will happen, the patient thoracic volume will get increased. Because of this volume increase, the patient thoracic pressure will get decreased, and since it's increased, the volume of box will get decreased. As the volume of box will get decreased, the pressure of the box will also increase. So this will goes vice versa. Okay, so this is what here I have mentioned in this diagram. At the sting of expiration, at the changes happened in inspiration. If you see at expiration, the flow signal is positive, and then your box pressure signal is negative during the inspiration. Okay, so again in that is expiration. So you know that the concept, as I said before, during expiration your lung volume is decreased. Okay, your thoracic volume is decreased. Since its thoracic volume is decreased, your pressure of thoracic volume is decreased, the box volume is increased, so pressure is decreased. So that's why the pressure curve is goes down and your volume curve is goes up. In case of inspiration, your lung is expanded, so your lung volume is increased. So box volume, because of this lung volume increase, the box spacious volume will get decreased. Since the box spacious volume is decreased, what happened to the pressure of the box? It also will get it will get increased. That's why at time of inspiration, the pressure wave goes down up positive side, and your volume curve which goes negative side. So in this way you will come to know what is the residual volume. So this is all about body lithosmography.